Oh, hi there. I was just doing some research on why 0 factorial equals 1. So, a factorial is like an n factorial is equals to n times n minus 1 times n minus times 2. This is, oh yeah, it is minus 1, 2 times n minus 3 and blah blah blah. So let's make an example, like 5 factorial equals what? It's equal to 5 times 4 times 3 times 2 times 1. You can't times 0 because if you times 0, every number that have a factorial would be equal to each other. So this is equal to 120 because 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 20, 120, 120 times 1 is 120. There's another way to do this, and that is to complete the pattern. So 4 factorial is equal to 5 factorial divided by 5. And that's 120 divided by 5, and that is equal to 24. Try it again. 4 factorial equals 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24 still. Now 3 factorial is equal to 4 factorial divided by 4, and that is 24 divided by 4, that is 6. Now 3 factorial equals 6. What about 2 factorials? Is equal to 3 factorial divided by 3. 6 divided by 3 equals 2. 1 factorial is equal to 2 factorial divided by 2, and this 2 divided by 2 equals 1. The moment of truth. 0 factorial is equal to 1 factorial divided by 1, and that is 1 divided by 1. It's 1. What about minus 1 factorial? Minus 1 factorial is equal to 0 factorial divided by 0, that is equal to 1 divided by 0. Wait, I just broke math. I broke math, guys. I broke math. I broke flipping math. This pattern over here is some reason is made out, but I'm not sure. Now, there's another way to recommend this. I have 3 creatures over here. How many ways are there to rearrange 3 creatures? That is 1, that is 2, that is 3, that is 4, that is 5, and that is 6. Now 2, take away 1, there's 1, 2. See that? 1 is one way to arrange it. Now 0, how many ways are there to rearrange 0 things? There's 1 ways. Want to see me do it again? Here it is. There we go. So that is 0 factorial equals 1. Now what about power? The power. What is 2 to the power of 2 equals 2? That is 2 times 2 equals 4. 2 to the power of 2 equals 4. What about 2 to the power of 2 to the power of 2? That is 2 times 2 times 2. That is equal to 8. Because this is 4. 4 times 2 is 8. Now 3 to the power of 3. That is equal to 3 times 3. Nope, that is not how you do it. Oh yeah, that is how you do it. But did I get it right? 3 to the power of 3 has to be... Oh crap. I do it the wrong way. Or maybe I did the right way. Yeah, it is 3 times 3 times 3. That is equal to 27. This is not how you do it. This is 2 times 2. Yeah, it is 4. But this one is 2 to the power of 4. That is equal to 2 times 2 times 2 times 2. This is 4, this is 8, this is 16. This is equal to 16. Now, what if I made this into Graham's number? Graham's number is G64. Now, to make G1, you have to do this. Let's start one by one. This is the first number. It is right in arrow notation as well. 3, arrow 3. 3 to the power of 3 equals 27. Now what about 3 double arrow 3? That is equal to 3 to the power of 3 to the power of 3. That is equal to 3 to the power of 27. That is equal to 7.6 trillion. Toad! We went from 27 to 7.6 trillion in just one more arrow. 3 to the power of 3 to the power of 3 to the power of 3. No, this arrow. And it is equal to 3 to the power of 3 to the power of 3 and something 3. And there are 7.6 trillion numbers. 3 in this notation. There are 3.6 trillion digits. 3.6 trillion digits. That's a lot of number, but that doesn't come close to Graham's number. To start with Graham's number, we have to start with 3 to the power, 3 to the power, 3 arrow 3. That is equal to, let's call it G1. Now we do it again. 3 arrow 3. There are G1 of this many arrows. That is equal to 2 G2. Now, to get to G3, you do it again. You have twice the amount of arrows. Well, this one has G2 of those numbers. Now, next, we need to, this is equal to G3. And you continue doing this until you have G64. Now, this is a small number. This is big. This is stupidly big. This is stupidly big. This is insanely big. Now, what do we have now? This is extremely big. Tree 3 is bigger than Graham's number, but I don't have an explanation for that. We'll wait until the next episode when I finally find an explanation for tree 3. Right now, this will wrap up the video. Goodbye, guys.